Okay, with this video I'm going to provide you the solutions to all the questions that are on the review sheet for the midterm exam. And first things first, I want to just kind of go through a few details with you. The midterm is in two portions. There's a calculator portion and a non-calculator portion. I'm not sure which the testing center will begin with you first, but make sure before you leave that you've done two different portions to this test. During the non-calculator portion, they will hold on to your calculator while you go back and finish the test. The calculator portion, the stuff that's on there, will be solving right triangles, determining arc length, finding coterminal angles, evaluating trig functions at points in the plane, evaluating sums, differences, half and double angles from right triangles. All things that you've done throughout the course. You've done these on your tests, you've done these in your homework. You know, these are just the major items. And the non-calculator portion will consist of similar things. There's a blank unit circle that's not for any points, but it will certainly help you move through the test a lot faster, I think, if you fill out the unit circle and use it. There'll be a blank one there for you. Evaluating trig functions at common angles, evaluating inverse trig functions, graphing trig functions, solving identities, evaluating trig functions using sum, difference, half angle, and double angle identities, and finally solving trig equations. None of these are really calculator dependent, so I feel like you probably would choose to not use your calculator in the test anyway. The things that you really certainly will need for the calculator will be on the calculator part of the exam. Okay, let's get started with the review, and we'll begin with question number 1. Number 1, find the angle of least positive measure that's coterminal with each given angle. Well, to find coterminal angles, you basically start with an angle measure that is outside of the range of 0 to 360 degrees or 0 to 2 pi radians. And you just need to add or subtract 360, 2 pi, whichever applies, in order to get into that range. So for 385, you're welcome to use your calculator on this part of the test. To get a coterminal angle with 385, that's larger than 360, so just subtract 360. And you get 25 degrees. So this becomes 385 minus 360 gives us 25 degrees. That's the smallest positive measure that's coterminal with that angle. All right, with negative 308, what we'll have to do is add 360 because this is lower than the range we need. So we need to get up into where we need to be. So I would just do negative 308 plus 360. Whoops. And just be careful to use a negative instead of a minus sign for the 308. But we get 52 degrees. Then 715, it's larger than what we need, so we need to subtract 360 degrees here. So 715 minus 360, that gives me 355 degrees, which is in the range that we want. So that's correct. Then negative 670, if I add 360 to it, it's still outside of the range that I need. So I actually need to add 360 a second time to get it into the range that I'm looking for. So the angle measure that's coterminal with 670 in this case would be 50 degrees. Number 2, using the formula S equals r theta, determine the arc length intercepted by the given central angle and radius. So S equals r theta, S is the arc length, and r is the radius of a circle, and theta is an angle measure. The only thing you have to be careful of is that the angle measure has to be in radians. So if it's not in radians to begin with, you have to convert. Other than that, this is pretty straightforward. So in part A, we have a circle whose radius is 10 meters. So let's say this radius is 10. We're looking at an angle measure of 1/2 radian. And then this region right here is the arc length that I'm looking for. And so I'm told that I can find that using S equals r theta. So the radius of this circle is 10. The angle measure in radians is 1/2. So 10 times 1/2 is 5. So essentially 5 meters in this case. For part B, I have a circle whose radius is 2 inches. And an angle measure that is 30 degrees. So the arc length that I'm looking for is, again, this arc that's intercepted by that. But the problem is, since 30 degrees is not in radians, I have to convert first. So 30 degrees times, remember you have to multiply by either pi over 180 or 180 over pi. And the way that's easiest for me to remember is I need the degrees to cancel out because I want to go from degrees into radians. So to get the degree to cancel out, I need to put the 180 in the denominator so that the degree will cancel. So I need to multiply by pi over 180. All right, so the 30 goes into 180 6 times. So this is an angle measure of pi over 6. So now when I do S equals r times theta, that arc length is going to be the radius of 2 times the angle measure of pi over 6. 2 goes into 6 3 times. So it's pi over 3 inches. Or if you wanted to approximate that, just get out your calculator, take pi divided by 3, and it's about 1.05 inches. Oops, 0.5, not just 5. Okay. Number 3. An angle theta is formed when a terminal side line passes through the point -4, 3. Find the values of the 6 trigonometric functions at theta. Answer using exact values. Now, we're on the calculator portion, but it is specifying to use exact values. And the reason for that is just we want the answers in terms of fractions or possibly square roots if necessary. You're welcome to use your calculator to simplify the square roots, that sort of thing, but the final answers do need to be in fractional form. Now, this is a pretty straightforward problem as long as you just remember the very basic rule, SOHCAHTOA. So SOHCAHTOA the princess of the trigonometry tribe tells you how the sides of a triangle relate to the trig functions sine, cosine, and tangent. If you've got that down, you can handle a lot of these problems. Now, the point -4, 3 is going to be in quadrant 2. And the reason I know that's in quadrant 2 is because the x-coordinate is negative and the y-coordinate is positive. So there's that point. Now, if I make a triangle, so technically this would be like my angle theta, and then you could consider this to be a reference angle, that's fine. But if I make a right triangle with respect to the x-axis, the x distance I traveled was -4 to get to that point, and then the y I traveled was 3. 3, 4, 5 triangles are something that you probably should know at this point, and so the hypotenuse is going to be 5. If you are unsure of that, that's fine. Just, know that you can figure it out using the Pythagorean theorem. A squared plus b squared equals c squared. So in this case, 9 plus 16 equals c squared, or 25 equals c squared. So c is technically plus or minus 5, but the hypotenuse would always be a positive number, so just positive 5. Now, the 6 trig functions, we'll start with sine theta, cosine theta, and tangent theta. So using SOHCAHTOA, sine is going to be the opposite side over the hypotenuse. So in this case, 3 over 5. Cosine is going to be the adjacent side over the hypotenuse, and tangent is going to be the opposite side over the adjacent, which I could write as negative 3 over 4 or 3 over negative 4. It doesn't really matter. It both means negative 3/4. All right, then the remaining trig functions, cosecant, secant, and cotangent. These are just the inverses of the first 3 trig functions. So just remember which ones go pair together. So cosecant goes with sine. It's the inverse of sine, so 5/3. Inverse of secant, negative 5/4. Inverse of tangent, negative 4/3. Number 4. Given sine alpha equals negative 15 over 17 with alpha in quadrant 3, cosine beta equals 4/5 with beta in quadrant 4, evaluate sine of alpha plus beta. Okay, so let's start figuring out a little bit about alpha. So alpha is an angle that's in quadrant 3, so I'll just sketch an angle in quadrant 3. And I know the sine of that angle is negative 15 over 17. So that's a hint as to what the opposite and the hypotenuse of that reference triangle is. The remaining side of the triangle, let's see, if I take the two known sides, so negative 15 squared plus x squared equals 17 squared, let's work with that. So 15 squared is 225, 17 squared is 289. So this would be 225 plus x squared equals 289, or x squared equals the difference of those two, should be 64. Yep, and that's a perfect square, which is nice. So x is plus or minus 8, and I do need to consider that to be positive or negative, depending on the quadrant. And since this is in quadrant 3, both the x and the y are negative, so negative 8 is what I want. Okay, beta is an angle in quadrant 4, so I'll draw that, make a reference triangle, and know the cosine of beta is 4/5. So the cosine is the adjacent over the hypotenuse, so this remaining side is going to be negative 3. And I know that because it's going to be a 3, 4, 5 triangle, and it's a negative 3 because in quadrant 4 the y's are negative. Okay, so I need to solve for sine of alpha plus beta. To do that, I'm going to need to use a sum identity. So the sum of the sine of two angles is going to be the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. And you'll need to be familiar with your identities that way, because a lot of your questions will involve an identity. So any of the ones that you have learned so far, make sure you know those so you have them ready to use on the test. You won't have a formula sheet or anything. You just have to memorize them. Alright, but using these diagrams I can figure out what these are. So sine of alpha is going to be, well, it's actually already given as negative 15/17. And same for cosine beta, that was given as 4/5. Cosine of alpha I have to figure out. I just found that last side, which was negative 8. That's the adjacent side of that triangle over the hypotenuse to give me the cosine. Sine of beta, similar, but in this case it's going to be the opposite, which is negative 3 over its hypotenuse of 5. Okay, so negative 15 times 4 is negative 60. 17 times 5 is 85. Negative 8 times negative 3 is 24. 17 times 5 is 85. When I add those together, I get negative 32 over 85. So that is the, oh, I'm sorry, negative 36 over 85. Excuse me, there we go. All right, so negative 36 over 85. That's what I want. And that's my final answer. Number 5, given sine theta equals negative 5 over 13 with theta in quadrant 3, evaluate cosine 2 theta. Answer using exact values. Okay, so angle in quadrant 3, I'll just sketch something out here. So here's theta. I know the sine of theta is negative 5 over 13, so that's the opposite over the hypotenuse. The remaining side, you might know this to be 12, but if not, use your Pythagorean identity again. And it should be a negative 12 because you're in quadrant 3. Now, cosine 2 theta, in order to figure this out, you just need to know the identity for cosine 2 theta is equal to cosine squared theta minus sine squared theta. So cosine squared theta is going to be negative 12 over 13 squared. Sine theta is going to be negative 5 over 13 squared. So in this case, it would be 144 over 169 minus 25 over 169. And if we subtract those two, I think it's 119, but let me just be certain. Yes. So 119 over 169, and I'm certain that that's not going to reduce. Number 6. Solve the following right triangle, round all values to one decimal place. Okay, depending on the given information is how you will go about solving these right triangles, but generally you have your trig functions and the Pythagorean identity at your disposal to work with. So in this case, I have two sides of the triangle known, so I'm going to figure out the third side using the Pythagorean identity. So I'm going to solve for side B. So b squared plus the other shorter leg squared is equal to the hypotenuse squared. Let me get b squared by itself by subtracting 26.5 squared over. And that is going to equal, let's see, 52.8 squared minus 26.5 squared, 2085.59. And when I take the square root of both sides, that's going to tell me that that length B is 45.7. So I should say that's an approximation, 45.7 meters in this case, although the units don't necessarily matter unless it's degrees and radians. Alright, now we need to solve for some angle measures. So I'll start with angle A. So to solve for angle A, it's this one up here, I notice I have the opposite side to that and the adjacent. So I could say the sine of angle A is 26.5 over 52.8. Or A is the arc sine of that. So that is going to be approximately, come over here on the calculator. I'm just going to make sure I'm in degree mode. Good. So arc sine 26.5 over 52.8. Now the problem didn't specify to answer with degrees, But when you are solving a triangle, generally you can assume that you're going to answer with degrees because that's the most common thing. But really, unless it specifies, you can use radians or degrees. So 30.1. All right, and then if this is 30.1, then the other thing we could do to figure out the remaining angle is, since I know two angles already, this one being 90 because it's a right triangle, all angles have to add up to 180. So really I could do 90 minus 30.1, and that will give me the other angle, so it should be 59.9 degrees. But if I wanted to be super careful, I could also solve for that by doing cosine of angle B is 26.5 over 52.8, so that B is the arc cosine of that. And when I plug that in, I should get the same answer. 26.5 over 52.8, and it rounds to 59.9. So that works out well. You generally would need to try and avoid using any calculated values, because let's say you typed in something incorrectly into the calculator when getting the value for angle A. That's going to make angle B inaccurate. So try to avoid it if you can. So the second route that I showed you is probably the best in this particular case. So don't use any values that you calculated. Use only known values from the problem. Number 7. Solve the following right triangle, round all values to one decimal place. All right, now in this one, we can use 90 minus 28.5 to find the remaining angle, because I'm calculating based off of a known value that was given originally. So 61.5. Now to solve for B and C, I think what I can do is just rely on sine and cosine. So if I did the sine of my known angle, 28.5 degrees, that's the opposite side, which is B, over my hypotenuse. And then if I did cosine of 28.5 degrees, that would be the adjacent side, which is C, over 13.3. So basically, B will be found as 13.3 sine 28.5 degrees. So 13.3 sine 28.5. So 6.3. And this is in inches, so about 6.3 inches. And then C, 13.3 cosine 28.5 degrees, which will be approximately what? 11.7 inches. There we have it. Okay, now that is everything for the calculator portion of the test. The remaining part of the test is going to be on the non-calculator portion. And you're going to be provided a unit circle which looks just like this, and was downloaded on the internet from embeddedmath.com. Feel free to visit their website if you like. I guess it could have been not lazy and made my own, but wasn't feeling too not lazy. Now, the thing that you're going to need to be able to do is fill in this unit circle accurately. You want to make sure everything is accurate so that your answers are correct when you use the unit circle to make answers based off of it. You want to fill it in completely because you never know what's going to be asked of you. So make sure you practice filling in a unit circle, and you can get a free one at embeddedmath.com. Now, the way that I do it is I begin with the degrees because I think that's the easiest thing for me. So the one thing you have to keep in mind is that there are gaps of 30 degrees and gaps of 15 degrees. So just pay attention as you're writing those in. So this is a big gap here from 0 to 30. Then there's a small gap, which is 15 degrees, so that next one's 45. Then the next one's 60. Then there's a 30-degree gap again, so that makes this one 90. Then 120, 135, and 150. 180, 210, 225, 240, 270, 300, 315, 330, and 360. All right, so all of the ones in degrees. Yeah, pretty straightforward. All right, now we're going to also want those in radians because you never know if the question is going to ask in degrees or radians. All right, so to get those, you can always fill in the ones you already know. Like this is 0, this is pi, this one's pi over 2, pi over 4. If you aren't sure which one's pi over 6, pi over 3, that's fine. I'll show you how to go about that. And it all comes down to the divisors of 12. So for instance, like you start with 0 pi over 12. And you have to kind of consider that these are in 15-degree increments. So the next 15-degree increment is pi over 12. Then this one would be 2 pi over 12, 3 pi over 12, 4 pi over 12. Right here would be 5 pi over 12, and finally 6 pi over 12. And if you reduce these fractions, 2 goes into 12 6 times, so this is pi over 6. 4 goes into 12 3 times, so this is pi over 3. So that helps you fill in those angle measures as accurately as you can. Then you can keep doing it. This would be 7 pi over 12, 8 pi over 12, 9 pi over 12, 10 pi over 12, 11 pi over 12, and 12 pi over 12. Okay, and you don't have to write in the ones you already know and have filled in, that's of course. All right, 8 pi over 12, the top and bottom are divisible by 4s, so you can cancel out the 4, and this would be 2 pi over 3. 9 pi over 12 is divisible by 3s, so that's going to give you 3 pi over 4. And then 5 pi over 6. Okay, then you go on to the next quadrant, so quadrant 3. So this one would then be 13 pi over 12. You can continue going this route. So 14 pi over 12, 15 pi over 12. You just keep going around until you have them all filled in. All right, reducing these, 14 pi over 12 would become 7 pi over 6. 15 pi over 12 would be 5 pi over 4. 16 pi over 12 would be 4 pi over 3. And 3 pi over 2. This point would be 19 pi over 12, 20 pi over 12, 21 pi over 12, 22 pi over 12, and then the remaining one there will be 23 and then 24. But I think it's pretty obvious that this is 2 pi. 22 pi over 12 would be 11 pi over 6. Then this would be 7 pi over 4 and 5 pi over 3. So there you've got it. Now, filling in the points. One thing that you need to make sure you're aware of is, like in quadrant 1, both the x and y are positive. In quadrant 2, the x is negative and the y is positive. Quadrant 3, the x and y are negative. And in quadrant 4, the x is positive, but the y is negative. Now, I start off filling out the quadrantal angles because those are pretty easy. Like if this was a point on the x-axis, it would intersect the unit circle at 1, 0. This one's at 0, 1 because it's on the y-axis. This is negative 1, 0 because it's on the negative x, and 0, negative 1. So just go ahead and fill in the quadrantals. They're pretty easy. Now, the ones that are the square root of 2 over 2, those are pretty easy as well. They're always the one that's in the middle. So root 2 over 2, root 2 over 2, just fill those in. And I'm neglecting the positive and negative just for a second. I'll fix that in a second. All right, so just remember that in quadrant 2, your y values have to be negative. In quadrant 3, both x and y are negative. In quadrant 4, in quadrant 2, the x value is negative. Sorry, my bad. So negative root 2 over 2. And then, if I can erase that nicely, there we go. Y values are negative in quadrant 4. So fill in those points, then take care of the positives and negatives. So basically, anything with a denominator of 4 in your radians is the root 2 over 2 and root 2 over 2. Anything with 6 in the denominator is going to be root 3 over 2 and 1/2. And anything with 3 in the denominator is going to be 1/2 root 3 over 2. So you need to know what's happening in quadrant 1. Learn a way of knowing that. Make sure you get those completely correct. And then build the rest of the unit circle from those. So anything with 3 in the denominator is 1/2 root 3 over 2. Take care of the negative where it's supposed to be. Anything with 6 in the denominator is the opposite. Make sure your negative's where it's supposed to be. So there's a 6, that's the root 3 over 2 1/2. Both of these are negative. And this is just going to be the opposite. All right, this has a 3 in the denominator, so it's 1/2 first. The y is negative. And there we have it. So make sure you have a way of filling in a unit circle accurately, because the questions you can answer off of that are much easier with one. All right, so let's move on. So I need to evaluate a bunch of trig functions at different angle measures. If I have my unit circle handy, and here's mine, it's a very straightforward thing to do. All right, so sine of 30 degrees. So sine is the y coordinate. It's going to be 1/2. Cosine of 90. So here's 90, and cosine is the x coordinate. So that's just going to be 0. Tangent of 240. So here's 240. Tangent is the y coordinate. Oops, I didn't mean to put an extra negative in there. Over the x coordinate. Here the 2's cancel out, so this basically becomes positive root 3. You can also do that by inverting and multiplying by the inverse of the denominator. It's going to work out that way. All right, secant 45. So 45 is here. Secant is related to cosine, so it's root 2 over 2. But recall, root 2 over 2 is a simplified version of 1 over root 2. You just need to invert that, so this becomes square root of 2. Sine of 315 degrees, there's 315, there's my sine. I don't need to do anything to it. Whoops, I'm sorry, that's cosine. But it's effectively the same, it's just a negative. Sorry. Sine is the y coordinate. Cotangent 270, there's 270. cotangent is x over y. So the x is 0 and the y is -1. So that's just 0 in this case. Then the next few here, secant of pi, pi is there. Secant is related to the cosine, which is the x-coordinate, so it's 1 over -1, or just -1. Cotangent of 11 pi over 6, the cotangent is x over y, so it's going to be √3 over 2 divided by what was on 11 pi over 6, so -1/2. So the 2's cancel, but I still have a negative, so this is -√3. Cosine 2 pi over 3. 2 pi over 3 is there. Cosine is the x-coordinate, so -1/2. Cosecant 5 pi over 4. Here's 5 pi over 4. Cosecant is related to sine, so it's going to be the inverse of this number, so -√2 for reasons that I mentioned earlier. Tangent of 3 pi over 2. Here's 3 pi over 2. Tangent is y over x, which in this case is undefined. So make sure you write in where undefined values happen and state it as undefined. Cosecant 7 pi over 6. There's 7 pi over 6. Cosecant is related to sine, so it's the inverse of that, which will be -2. So as you can see, having a unit circle handy can really make stuff like this a lot faster and easier to do. Number 9. Determine the values of theta in the interval 0 to 2 pi that solve the following. Starting with sine theta equals -3/2. So again, unit circle is going to be great. So sine is where the y-coordinate is. So I need a y-coordinate that's at -3/2. So there's one, and there's another. This is solved from 0 to 2 pi, so answer in radians. So 4 pi over 3 and 5 pi over 3. Oh, sorry. I was thinking to myself how that 5 looked like a 6. Well, it still does. There. Now it looks like a 5. But that's why I wrote 6 in the denominator. Anyway, moving on. Cosine theta equals 1. Cosine is the x-coordinate. The only time that equals 1 is at 0. Tangent theta equals √3 over 3. Alright, so to figure this out, just kind of consider, tangent is, of course, sine theta over cosine theta. √3 over 3 is simplified form of 1 over the square root of 3. So effectively, we want -1/2 over √3 over 2. So the sine has to be 1/2, the cosine has to be √3 over 2, but one of them has to be negative. It can't both be negative because then it would become a positive result. So I need this to be opposite signs. So let's see. Well, I could do this as well. So all students take calculus. So all students take calculus. So tangent is going to be negative in quadrant 2 and in quadrant 4. So my only solutions are going to be in quadrant 2 or quadrant 4. Alright, so I need sine to be 1/2, cosine -3 over 2. So there's my two answers. So at 5 pi over 6 and 11 pi over 6. Number 10. Find the exact value in radians of the following. So part A, I have the arcsine of -1/2. In order to do this, if you have a few of them, it's going to be best to have your unit circle handy. right? So I've got mine, and the arc sine of negative 1/2, just remember, sine is going to have to answer in quadrants 1 or 4. But if you're answering in 4, remember the range on this is from negative pi over 2 to positive pi over 2. So instead of 3 pi over 2, you would answer negative pi over 2. Instead of 7 pi over 4, you would answer negative pi over 4. 11 pi over 6 would be negative pi over 6. 5 pi over 3 would be negative pi over 3. So you answer from negative pi over 2 to positive pi over 2. Just be careful there. All right, now this is going to be in 4 because the half is negative. So I'm looking to where the y value, because sine is associated with the y value, is negative 1/2. And that happens right here when we have the angle measure negative pi over 6. Okay, now the next one, for B, the cosine of the arc cosine of square root of 2 divided by 2. So cosine, we answer with arc cosine in quadrants 1 or 2. Because cosine could be positive in quadrant 1, but negative in quadrant 2. So we can get all the different values from those two quadrants. All right, so root 2 over 2 is a positive number, so this is going to be coming from quadrant 1. So I need the cosine, which is the x-coordinate, to be the square root of 2 over 2. And that happens right here at the angle measure pi over 4. Okay, now the last one, let me scroll down a bit. Okay. The arctangent of negative square root of 3. The problem with doing tangents, cosecant, and secants is that we have the x and y values for sine and cosine explicit, but we don't have, y divided by x written on our unit circle for tangents and that sort of thing. So what we have to do is, manipulate a little bit until we get things working the way we want. So first things first, we need to know that tangent's either going to answer in terms of quadrant 1 or quadrant 4. Since this is negative, we're going to be in quadrant 4. All right, now, the tangent of an angle measure is, of course, the sine of that angle measure divided by the cosine. So keep that in mind. So I'm trying to get something to where I have a square root of 3 involved. Now, in order to get this negative square root of 3, what I'm going to do is, since I know my choices for sine and cosine are square root of 3 over 2, 1/2, square root of 2 over 2, 0, 1, and that's about it. So what I'm going to do is I'm going to pick square root of 3 over 2 divided by 1/2. Because I know that those two things can happen at the exact same angle measure. And if I take square root of 3 divided by 2 and divide by 1/2, which means to multiply by the inverse, that's equal to the square root of 3, which is the value that I have, except mine is negative, so I'm just going to make one of these negative, and that's fine. Now what I'm looking for on my unit circle is an angle measure for which the sine of theta is a negative root 3 over 2, and the cosine of theta is 1/2. So that is right there, which means the answer here is going to be negative pi over 3. It is tempting to write 5 pi over 3, but just remember with these arc tangent, arc cosecant, arc sine, the range is from negative pi over 2 to positive pi over 2. So you do answer with negative angles when you're in quadrant 4. Number 11. Given the function y equals 2 cosine 4 times the quantity x minus pi over 4, answer the following. Number 1, what is the amplitude? Okay, the amplitude is the number that is multiplying your function. So in this case, it's 2. So that's the maximum distance that the function goes away from the horizontal axis. What is the period? So the period is normally 2 pi, but then it's affected by this number. So we take 2 pi over 4 and reduce. So the entire cycle here finishes up in a factor of pi over 2. The phase shift comes from this number, and it tells me, because it's negative, I'm going to go to the right by pi over 4 units. And part D, draw a graph of one period. Okay, so cosine generally begins at its maximum, goes down to its minimum, and back up its maximum in a distance of 2 pi. But that's happening now in pi over 2. But I'm not starting my cycle at 0, which I usually would, so I would start my maximum here at 0. Everything's getting shifted over pi over 4 units, so that maximum is going to go to there. Alright, and I'm going to end my cycle. If I'm starting at pi over 4, and I have to end it after a distance of pi over 2, so that's pi over 4 plus, 2 pi over 2. 2 pi over 4, which would be 3 pi over 4. So I need to finish by 3 pi over 4. Alright, now I'm going to reach my minimum halfway in between that interval, just because I know that I'm going to make this, periodic function of a wave. And then here and here, which is the middle of those intervals, I'm going to be at my axis. So the cosine is going to look something like this. And that is one period of the function. Number 12, graph one period of y equals 2 cosecant 2 times the quantity x plus pi over 2. Basically the same thing as graphing sine. Sine and cosecant are related. In fact, that's what I'm going to do. I'm going to graph sine first and then fill in what cosecant looks like. All right, so same things again. I'll do the sine in green. So everything involving sine in green. All right, so this is an amplitude. This is my period change, which normally is 2 pi, but now it's divided by that factor. So this period is 2. And this is a shift to the left by pi over 2 units. All right, so normally sine starts off at 0 right there. But everything's getting shifted to the left by pi over 2. So this is coming over here to negative pi over 2. So that's my starting point. Now my period is pi, so that means starting with negative pi over 2, I add pi, and that's going to give me positive pi over 2. So that's the end of my interval. So I'm going to finish my cycle back over here. All right, now the way the sine wave works, it goes up to its maximum, back to 0, down to its minimum, back up to 0 again. So in the middle of this interval, I'm going to be at 0. The middle of that first half is going to be up at a maximum, and of the second half, I'm down at a minimum. So my sine wave looks like this. Okay, but I'm not graphing sine, I'm graphing cosecant. So the inverse of that's what I want. Anytime sine is 0, the inverse of 0 is undefined, which means you have an asymptote. So whenever sine is 0, draw in an asymptote. Okay, whenever sine's at its maximum, cosecant is at its minimum. and vice versa over here. And then cosecant just kind of has a U shape above and beyond that. And there you go. That's a perfectly acceptable graph. Number 13. Graph one period of y equals tangent of x minus pi over 4. Okay, so graphs of tangent and cotangent, you just kind of have to remember some basic things. First off, their period is just pi. And tangent is an increasing function. Cotangent is a decreasing function. Tangent generally has a passes through the origin, whereas cotangent is undefined there. Now, this right here is a shift, and it's shifting everything to the right by pi over 4 units. Okay, so normally tangent has this point at the origin, but everything's getting shifted over pi over 4 units, so it's going to move to right there. Okay, and tangent generally has an asymptote at negative pi over 2, but that's going to get shifted over pi over 4 units. And it generally has an asymptote at pi over 2, but that's going to get shifted over pi over 4 units. So everything just getting shifted over. And then tangent has this kind of curve that looks like this. So once you know where the asymptotes and the 0 is, just draw in the shape. It's an increasing function, so it goes up in value from left to right. Number 14. Establish the identity 1 plus tangent theta over 1 plus cotangent theta equals tangent theta. Alright, so I will start with the left-hand side. And sometimes problems will say establish the identity, prove the identity. You know, it's all the same thing. We want you to start with the left-hand side of the equation and work to the right-hand side, or vice versa. Generally, I just pick the side that looks more complex because there's more stuff to cancel. Canceling is easier than putting stuff in that doesn't exist. Okay, one great method is to just write everything in terms of sine and cosine. So for instance, I know that tangent is sine over cosine, and cotangent is cosine over sine. And it doesn't look like much can be done, but it gives me fractions in the numerator and the denominator that can be combined. But I'd need to have common denominators. So this 1, I'm going to rewrite as cosine theta over itself. And in the denominator, I'm going to rewrite the 1 as sine theta over itself, just so I get a common denominator. Okay. So in the numerator, I can combine those two into a single fraction. So this would be cosine theta plus sine theta all over cosine theta. Then the denominator would be sine theta plus cosine theta all over sine theta. Now I've got a compound fraction, and we can take care of compound fractions by inverting the denominator and multiplying. So let's do that. So cosine theta plus sine theta over cosine theta times the inverse of the denominator, which is sine theta over cosine theta plus sine theta. Since they're added, I can reverse them, that's fine. But there's a factor of this and a factor of that in the denominator. The whole thing will cancel out, leaving me with just sine theta over cosine theta. And that becomes tangent theta. So now I've reached the right-hand side of the equation, and I'm done. That's it. Number 15. Establish the identity sine theta over 1 plus cosine theta plus 1 plus cosine theta over sine theta equals 2 cosecant theta. Alright, so again, I'll start with the more complex looking side because it's much more likely that I'm going to run into things that can cancel. Okay, so my first instinct here is to try and combine these into a single fraction. But I'm going to need a common denominator. In order to get that, I would need to multiply the first fraction by sine theta over itself, and the second fraction by 1 plus cosine theta over itself, okay, so starting with the first part here, so this right here, I have two fractions that are multiplied. The numerators match, so I'm going to write those as sine squared theta. The denominator I'm just going to leave as sine theta times 1 plus cosine theta. In the next fraction, this part over here, I'm going to multiply those. I'm going to multiply numerators as well, but I'm going to FOIL those numerators. So I would do 1 times 1, so the first, which would be 1. The outer two, so 1 times cosine theta is cosine theta. The inner two would be another cosine theta. And the last two would be cosine squared theta. All right, now this denominator could be written as sine theta times 1 plus cosine theta as well. Okay, now at this point, I am thinking to myself, all right, I see a sine squared and I see a cosine squared. Those are probably going to cancel out to 1. So I'm working on going that direction now. And because my numerators are added together, I can do that. I can write, sine squared theta plus cosine squared theta plus 1, and then I have 2 matching cosine theta, so plus 2 cosine theta. And that's going to go over my common denominator. All right, so sine theta plus cosine theta, those add up to 1. And then I have 1 and 1, which will add together and give me 2. Okay, the numerator looks very similar to the denominator here, especially if I factor out this common factor of 2. So if I factor out that 2, I would have 2 times 1 plus cosine theta over sine theta times 1 plus cosine theta. So if you'll notice, here's two terms that match and can cancel out, leaving me with 2 over sine theta or 2 cosecant theta, which is what the right-hand side of the equation is. So I'm finished. Number 16. Find the exact value of cosine 105 degrees using a sum or difference identity. All right, so cosine of 105 degrees could be written as the cosine of 60 degrees plus 45 degrees. And the important thing about that is I can use the sum identity for cosine and write this as cosine of 60 degrees times the cosine of 45 degrees minus the sine of 60 degrees times the sine of 45 degrees. So using an identity there. And all of these are known values. You can use your unit circle, but these are all in quadrant 1, so you should have these handy. cosine of 60 is 1/2. Cosine 45 is root 2 over 2. Sine 60 is root 3 over 2. Sine 45 is root 2 over 2. So root 2 over 4 minus root 6 over 4, giving me root 2 minus root 6 over 4. Number 17. Solve the equation for all values in the range 0 to 2 pi. 2 sine squared theta minus 3 sine theta plus 1 equals 0. Okay, we need to factor this thing because it's a quadratic. In order to factor it, just use your basics. What are two things that multiply together to give you 2 sine squared? Well, 2 sine theta and sine theta are your only options. And what are two things that multiply to give you 1? So 1 and 1. Then you need to get the middle term to add to -3. So I think if both of these are negative, that's going to work out. Because 2 sine times -1 is -2 sine minus sine theta works out. Okay, so now that they're factored, we set each of those factors equal to 0 and solve. Oops, got minus there. Okay, so 2 sine theta equals 1, or sine theta equals 1/2. So we want to figure out where sine of theta is equal to 1/2 from 0 to 2 pi. So there and there. The rest of the angles would be in negative. So pi over 6 and 5 pi over 6. And then solving the other one, moving the 1 to the other side of the equation, sine theta equals 1. That's going to happen right there. The y is 1 at pi over 2. So theta equals pi over 2. And those are the 3 angle measures that will solve those equations, or solve that equation.